Do 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 do. All right, welcome to our next video in the series on stoichiometry. So we've been talking about gravimetric stoichiometry. Gravimetric is studying masses and dealing with different masses in our stoichiometry calculations. Given a mass of a substance, find a mass of another substance. Now we're moving into solution or volumetric stoichiometry. And as it says here, these are stoichiometric calculations of substances in solution. So we're doing these reactions in a solution. And because we're doing it in solution, we are going to be using concentration. And I just put here that that's big M in our for molarity. And volume, I don't think that V should be there, instead of mass and molar mass. So it's actually going to be all the same steps as before with just a small little change. And we'll see what they are. So let's scroll down here for these steps. So number one, balance the reaction including states. That is still the exact same thing we were doing before. Number two, identify the given and unknown, same as what we were doing with gravimetric. However, we're going to list C and V for each of these. So those are our variables that we are using, C for concentration, V for volume. And remember, concentration is given in moles per liter or molarity, and volume should be given in liters. So if we're given it in milliliters, which we often are, we have to make sure that we convert. So rather than masses and molar masses, we're going to write down concentrations and volumes. Number three, convert the given quantity into moles. That's what we did before. Before we were doing N equals little m over big M. Now, because we're dealing with concentration and volume, we're just going to use this rearrangement of the concentration formula, N equals C times V. Same thing for number four then, use mole ratio to find moles of unknown. That's what we were doing before. And then finally, number five, we're going to convert back to either concentration or volume, depending on what we're being asked to find. And that would be for our unknown. So again, rather than using that N equals little m over big M and then rearranging to find a mass, now we're going to find either concentration or volume. But you can see the steps are basically the exact same thing over again. The only differences are concentration and volumes instead of masses and molar masses. So let's do an example here. Take a look at how this works. So our example number one, a 0.010 liter sample, or that would also be 10 milliliters sample of sulfuric acid was reacted with 15.9 milliliters of a 0.150 molar, remember this M here stands for molar, potassium hydroxide solution. What is the concentration of sulfuric acid? All right, so step number one, write and balance our reaction. So we have sulfuric acid, so that's H2SO4, and we should write states here. I don't know whether I've ever mentioned it, but all acids are going to be given in aqueous, so that's easy enough. Plus, it's reacting with potassium hydroxide, so that's KOH, and if we take a look at our table, that would be aqueous as well. It is highly soluble. What is the concentration of sulfuric acid? So we aren't actually given our products here. We're going to have to look at them. This is an acid-base reaction. Remember, the hydrogen is going to go with the hydroxide to give us water, and the potassium is going to go with the sulfate here. So we're going to get K2SO4. If you take a look, that's going to be aqueous, and we're going to get HOH or water, and we'll put that as liquid. So let's go ahead and balance. We need a 2 here, and I think a 2 here, and that should give us a balanced reaction. So there's step number one. Step two, identify our given and our unknown. So we are given 15.9 milliliters of a 0.150 molar potassium hydroxide solution. So we know a lot about potassium hydroxide, so that's our given. We're asked what is the concentration of sulfuric acid. That's this one over here, so this is our unknown. So in this case, both of what we're working with is on the reactant side. That's not uncommon, so just make sure that you realize that. So we're supposed to list concentration and volume for each of these. So our concentration of potassium hydroxide is 0.150 molar. Our volume was 15.9 milliliters, which we always want to convert to liters. So we'll divide by 1,000 to give us 0.0159 liters. What is the concentration of sulfuric acid? We're asked to find this, and we're given a volume. It said a 0.010 liter sample. So we've identified our given, our unknown, written down what we know about them, and now we just go through those same steps that we've been doing before. So we're going to convert these into the number of moles. So for potassium hydroxide, now we do N equals C times V. So 0.150 molar times 0.0159 liters, and that gives us 0.00235 moles. And I didn't show unit cancellation here. Moles per liter can also be written, or molarity, I should say, can also be written as moles per liter. So you can see if we wrote it like that, liters are going to cross out, and we'll just be left with a unit of moles. So we've converted to moles, same as gravimetric stoichiometry now. We use that mole ratio to convert to moles of our unknown. So our mole ratio step here is X moles of our unknown, so H2SO4, divided by that value we just got, 0.002385 moles of KOH. On the right-hand side, we take the coefficients from the balanced equation. So H2SO4 was on the top, so the coefficient here should go on the top. That's just a 1. And KOH was on the bottom, so the coefficient from KOH should go on the bottom here, so it's just a 2. What are we going to do? We're going to do 2x equals 1 times this number, which is just this number. So we're really just going to get x equals 0.002385 divided by 2. And that gives us 0.0011925 moles of H2SO4. So finally, we now need to convert the moles of H2SO4 into, in this case, concentration. That's what we're being asked to find. So for H2SO4, we want to find concentration. So concentration is N divided by V. We just calculated out how many moles, so 0.00111925 moles, divided by a volume. We were given 10 milliliters, or 0.010 liters. And when we do that, you get 0.11925. And we should round to significant digits. If we take a look at all of our initial measurements, this was the one that limits us. This only has 2 significant digits, so my answer should also only have 2 significant digits. So it should be 0.12, and then our units either could be moles per liter, or I prefer molarity. But either way is absolutely fine. So same steps as with gravimetric stoichiometry, with just a small change. So write and balance your reaction, identify your given and unknown, convert to moles of your given, use the mole ratio to convert to moles of your unknown, and then finally go to either concentration or volume for your unknown. I've put a second example here. It's all worked out for you, just so you have another example of this being done. I'm not going to scroll down here. You can take a look at that on your own. Now, once you've practiced a few of those, so on that worksheet you can practice just some of the solution stoic questions first. Then we can give you questions, and you have all the knowledge necessary now to do any sort of gravimetric and solution stoichiometry question that may have them combined together. So let's take a look at this example and see what I mean by combined. So it says exactly 200 milliliters of sodium phosphate, PO4, that's phosphate, right? I better check that. PO4 phosphate, yeah, sodium phosphate was reacted with calcium bromide. Calculate the concentration of sodium phosphate if 16.5 grams of calcium phosphate was produced. Okay, so let's see before we get to see that this is a combined question, let's do the first step, which is the same regardless of any Stoic question. Write a balanced reaction. So we have sodium phosphate reacting with calcium bromide, and those were both aqueous. And it says calculate the concentration if calcium phosphate was produced. And we can see this is a double replacement here. The sodium and the calcium should swap with each other. In this question, we actually give you one of the products, calcium phosphate, so Ca3PO4 and that's a solid. This is a precipitate. The other one would be the sodium and the bromine going together. So that would give us just NaBr. And if you take a look, that should be high solubility, sorry. So that's aqueous. Go ahead and balance it. So we're going to need a 3 here to balance the calcium, a 3 here to balance out the sodium, and I think that actually, nope, sorry. To balance the phosphate, we need a 2, and this should be a 6 over here. Whoops, 6 NaBr. Okay, so we've got this balance. Now let's identify our given and our unknown and what we know about them. So we're supposed to find the concentration of this. So this is our unknown right here. And what are we given lots of information about? I believe we are given 16.5 grams of calcium phosphate here. So this is our given or our known. Okay, so why don't we just say that right now? We know a mass of this. We were given 16.5 grams, and we can calculate out the molar mass as well. I'm just going to give you that number, 310.18 grams per mole. You can do that calculation on your own, but it should be 310.18. So we're given a mass and a molar mass, so this looks so far just like a gravimetric question. What about for our unknown? Well, wait a sec, we're given a volume of our unknown, right? So we're given a volume of 200.0 milliliters. This is looking like a solution Stoic question since we're given a volume and we're asked to find concentration. So we've got gravimetric over here, solution over here, so this is a combined question. While we're at it, let's just convert this to liters, so this would be 0.2000 liters. All right, same things, same steps though. So we need to find the moles of our given. So for the calcium phosphate, we want to find moles, so N equals little m divided by big M, so 16.5 grams divided by 310.18 grams per mole gives us 0.0053 moles. There's our first step. That's just like a gravimetric question. Now we use our mole ratio to convert to moles of our unknown. So we want to find X moles of, what are we looking for here? Na3PO4 over 0.0053 moles of Ca3PO4. Over on the right hand side, grab those coefficients from our balanced chemical equation. So the sodium phosphate was a 2, the calcium phosphate was a 1. So we're going to have 1 times X equals 2 times this number. So we'll just get X equals 0.106 moles of Na3PO4. So mole ratio. Now we want to do the final step, and what are we supposed to find about sodium phosphate? I believe we're supposed to find a concentration. So concentration equals moles divided by volume. So we just calculated out the moles was 0.106. And the volume, we were given that way back at the start, 0.2000 liters. And when I do that, I get 0.532. And I believe that's rounded to the correct number of significant digits. And this would be moles per liter, or my preferred 0.532 molar. Either answer is totally fine. I'll put a box around both. I'll divide that box up so that you know, hey, I could have either answer. I don't need to write both. So this was a combined question. It was basically the same as any other one though, right? Write and balance the reaction. Figure out what we know and what we don't know. Figure out moles of our given, either using this formula or N equals C times V. Use your mole ratio to convert to moles of your unknown, and then convert to whether you're looking for whatever your final unit is, whether it's concentration or volume using this formula rearranged, or whether it's a mass using the N equals M divided by big M formula. It's all going to be the same steps over and over and over again. So as I said, try out these questions. There's 2 mixed ones. There's 4 or 5 solution ones. Maybe try the solution ones first before moving on to the mixed ones. So good luck, and may the force be with you.